I'm Stuart Lawn, and this is another in the pop-up Fab Lab series. Today we're in Leo Scarf's workshop here, and we're going to be talking to Leo about designing and making with CNC machines. Leo is reclining on his large CNC. Do you want to just tell us what this machine is?
Okay, well this is an 8x4 bed CNC machine. CNC stands for Computer Numerical Control, which means that basically the computer and the computer software can actually manipulate where the machine head moves on this bed. So you can basically cut out lots of parts of any profile using the router that is inside this head here.
Okay, perfect.
Yeah.
So this product here, you designed and made with the CNC machine, yeah?
Yeah. So this is one of the products that we've been working on the last little while, and it's called the Elevate computer stand, which basically enables you to raise up the monitor and the keyboard for use if you wanted to stand up rather than sitting down.
Or you can get it at the right sort of height ergonomically for sitting even.
Yeah, so you can have monitor here, you can have keyboard here, you can vary these simply by taking it out and slotting them in different heights. So we can take that out, we can raise that one up. So it just enables you to have lots of variation in terms of the height that you work at. So it's a perfect product in terms of cutting it with CNC.
So could you just talk us through how you kind of designed this so it all fitted together with all the parts?
Sure, yeah, well, you know, the idea was basically to have these shelves or these kind of tabletop areas that could be, you know, raised and lowered into these slotted holes. So, you know, we simply worked out the drawing to accommodate shelves. So we've got a part here at the back, which is a very simple, straightforward part. With those slotted holes, and then it's got the arms that actually support it. So it's a straightforward part. You know, it really didn't take that long in terms of. Did you design
that in 2D or 3D, or did you just kind of have it in your head how it was going to angle?
I kind of had it in my head for a while in terms of how it would work. You know, what you need to do, of course, with kind of keyboards and monitors is that you have a slight kind of variation in terms of the depth at which these things are. So by having that angle, it just means that you can have the keyboard closer and you can have the monitor further back.
Yeah.
So the higher up you go, the further away it gets. So, you know, it's a very simple way of kind of ergonomically, kind of, you know, arranging what you're trying to do.
Perfect, brilliant. So we'd like to see the CNC machine in action. So is there a part here that we could maybe kind of cut out and show how the CNC actually works?
Sure, yeah. Well, I had thought what I want to do today is make a slight variation of this part here, which is at the moment it's 12 mil. What I'd like to do is to make it in 15 mil. Which is just slightly thicker. It just means that it might perhaps give it that little bit extra strength.
Yeah.
And there's a slight variation in terms of the slots as well. I'm just kind of playing around with the exact spec. So this part here, I've got it set up on the bed here to cut.
Perfect. So what we'll do is we'll jump over to the computer and go through the sort of like setting up the file for the CNC onto the computer, and then we'll come back and we'll actually get the part cut out on the CNC.
Is the Vcarve Pro software, which we use for the CNC machine. And this is the opening page here, where you can set up a job here on the left hand side. So the first thing here is the job type. This is a single-sided job, so that's selected there. The job size, in this case, we're just doing a sample, so we're going to cut a small part. The width here of the part of the piece of wood that we're going to cut is 430 millimeters, and the height of it is 550 millimeters. And the thickness we're going to use is 15 millimeters. It's a 15 millimeter birch ply sheet. The 0 position is the position at which the router bit starts. Now you can have it starting on the machine bed, but we're going to have it start on the material surface, and that little diagram there just shows you the point at which it's going to start. Bottom left is normally the starting point. We want to use the offset position, which is that bottom left hand corner, and that's pretty much it. And we're on to a range of tools that enables us to set up our drawing on our piece of wood here. Okay, so the first thing we do is import the drawing that we need. Okay, so that's the particular drawing that I need. It's a DXF file. I'm going to open that, and it brings it into our work plane, and we can now see that the particular part that we're going to cut is centered on our sheet of wood. So you can see that it's still highlighted. That enables us to do one other thing before we actually place the part on the sheet, which is we need to join the vectors together. So all of those lines and any radiuses, we need to join them together to create one single unit, so the machine doesn't stop, start, stop, start. So we do this here, join vectors. Okay, and you can see that it's now not selected, so all those parts are joined together. If we just click on it, you can see that each individual part will be a cut line. Next, we need to move along to our toolpaths and set up a toolpath. So over here, we can choose from a range of different options related to how we want the router bit to cut. We're just looking for a simple cutout here. With the internal holes cut out. So we go to the profile toolpath, and here it enables us to set a range of options related to the tool. First of which is the cutting depth. This is a 15 millimeter sheet of wood, so I normally add about 1.5 millimeters. So the start depth is 0, and then the cut depth should be 16.5. Now the tool that we're going to use is an end mill bit, which is a very standard bit simply for cutting straight through sheets. We can select from a range of other tools here, end mills, ball nose V-bits, and a whole range of others. So all of those are set for us. We can OK that. And the next thing we need to do is set the amount of passes it's going to take. Normally with a sheet like this, 15 millimeters thick, we'd have about 3 passes. So that's OK. Next, we need to set the tabs. Now, tabs are small sections of wood that we leave at particular points on our part to enable it to stay in one place. If we don't add tabs to smaller parts, they could jolt and move around, which would obviously damage our part. So if we add a few tabs, it should keep it in place. So we just add a few of these maybe 4 should be fine for a part of this size. Next of all, we see a tab here at the bottom, calculate. So we can calculate how long it's going to take and whether our setup has been correctly formatted. So this comes up, it tells us that it's going to cut through the material. It also reminds us that we need to have a sacrificial layer underneath the sheet that we're going to use, just so that we don't cut into the machine bed. Okay, so that's okay. We'll approve that. And it's now showing us the tool path it's going to take to cut out our part. We can also preview that tool path. We just reduce the speed here so we can see it. And we just press play, and it shows us then that part being cut out there. You can see that it cuts each line 3 times, and it's also leaving those little tabs in place. That's good. We can close that now. And once we've selected our tool path, we can then go to this command here, which is save the tool path. And we can just click save tool path. It goes into the folder you want to save it in. We just key in the title of our file and save that. Okay, so we are ready to go now. We have our saved tool path. We can now transfer this file across to the CNC machine.
Okay, so I'm just going to explain a little bit about how this machine works. What we have here on the bed is a system that enables a vacuum to be created, which in essence sucks this spoil sheet down. You can see there's a vacuum bed there. So the pumps at the back of the machine suck air through holes and through these channels here, which basically draws the spoil sheet, sucks the spoil sheet down. So when we put our sheet of wood on top, the air is actually drawn through the spoil sheet and sucks, whatever you put on top, sucks it to the bed. Just as an extra precaution, because we have a small piece of wood, we're going to screw it down just so that it definitely doesn't move around. Okay, so I'm just going to explain a little bit about the machine here. What we're looking at here is the main spindle head. The spindle is this block here, which houses our router bit. The router bit is the part that actually does the work for us. So we use different types of router bit to shape whatever parts we need. So this bit here is a 10mm bit. That could be used then to cut out various profiles. That's called an end mill bit, which is simply a straight cylinder, which is generally used just for cutting out parts, not for routering into the wood or creating any profiles. So it's just a straight cutting bit. So that is housed in this collet. It's called a collet, which clamps the bit in place. That is then inserted into the spindle here and clamped in place. There's a guard then that slides across and covers the bit up. Okay, inside here today we've got a 6mm bit, which is generally used for cutting smaller profiles. So if we want to cut that very sharp corner there, we would use a smaller bit. So we're all set up to go there. Just to explain a little bit about how the head works, we need to position our router bit here directly over the very corner of our sheet that we're planning to cut. So what I'm going to do is I'm going to position it just do this by eye. Okay, so I'm basically setting the machine to start at that corner. So I've just set the X and the Y axes, and I'm now going to set the Z, which is the height at which the router bit is going to start on our sheet. Okay. How we do that is we use this little sensor here, which we sit on the very corner of our block, and once the router bit comes down, it will stop at that point, and it tells the machine that at that particular point here, you know, in terms of height, that's the starting point. Okay. Now, that's done. Okay, so the machine is now set up and ready to go. It knows that that corner point of our sheet is the starting point by which to cut our part. Okay, so just to talk a little bit about how the dust is extracted from the bed. The router bit, which is housed in here, has this cage around it, which sucks any dust up and out through these tubes here and back to our collection unit in the corner of the room here. We've set up our file that we need to cut on Vcarve, and we've saved that file as a TAP file format. So we've got our file on our stick here, and we're going to insert it into the controller. So this handset here is used to basically manipulate the head to create our starting point, and it also enables us then to load whatever file that we need to cut. So I'm just going to call up the file now. We can scroll down. We need to scroll to this comp3 TAP file and select that. And we're pretty much ready to go then. We need to switch on the machine.
Our piece is finally cut out, and there it is in all its glory. So obviously there is some kind of cleanup to be done after this. We were saying when you look at it, the kind of the edges are a little bit rough there, but the you know, the corners are nice and kind of smooth. So it does a really good job on that. I saw you when you were kind of like taking it out of the bed there, you were using the knife to kind of like cut through. What were you doing there?
Okay, so what I was doing was just cutting off the little tabs that are left here.
Oh, that's right. You put the tabs on when you were sort of like laying out the drawing in the.
That's right.
Vcarve.
Yeah, we leave maybe 4 tabs on a piece of that size. It just helps to keep it on the bed. It stops it moving around.
Yeah.
Because if it did move slightly, the router might just cut into the edge.
Yeah.
So you need to keep it in one spot.
That's not such an issue when the pieces are smaller like that. You don't really need to kind of
Well, those parts, those slots, we were actually cutting the part away, so we don't need the piece in the middle.
Yeah.
We can put tabs on those as well, but it's not really needed
Not really
in
necessary,
this particular piece. But what we do now is we clean off the edge. In this case, I'm planning to do a small router just on the edge, maybe a 2mm radius edge. So I'll run that around the machine on just in the other room there, which cleans out everything up, and then it'll be sanded, probably with about 3 grades of sandpaper, and then it goes in for finishing.
Right, okay. The CNC here is great for sort of like cutting out sort of like these big parts in bulk. Obviously, we have a huge bed here. We can make, very large kind of, parts, full, kind of.
Yeah, of course.
Furniture.
I mean, what we use this for here is making very often custom jobs where we might only need, a single part, or we might need 5 or 10 units of a part. So it enables us to kind of, to use it for a wide variety of things. Like we could, for instance, cut maybe 10 or 12 of this particular part out of one sheet here.
Yeah, exactly.
And you can have very, very small parts, or you could go right up in size. So just by having the 8x4 bed size, it enables a whole variety of things to be done, because 8x4 is the standard size of sheet.
Brilliant, that's excellent. Okay, so that's great. We'll have a look at that when it's finished.
Right. It's a lot stronger anyway.